Not an earthquake, but a mega earthquake could happen in Japan. It's scarier, bigger, and more destructive than ordinary tremors. However, the problem is that it will occur underwater, which means it will trigger a giant tsunami 100 feet high. A column of water nearly as high as a 10-story building will collapse on coastal cities, wiping out hundreds of houses. The water flow can destroy everything in its path like a bowling ball that knocks down pins. And then another wave may come, and another one. Anyone who is at risk should be on their guard. How to survive? You'll find out later in this video. But first, let's find out what a mega earthquake is. This is an earthquake with a magnitude 9 or more. This is a very rare phenomenon, and it depends not on the power of the shock, but on the length of the fault where it occurs. The longer the fault, the stronger the earthquake. But what are these faults? These are cracks in the rocks of the Earth's crust that move relative to each other. Imagine a large puzzle where every detail is a giant tectonic plate. When one part of the puzzle moves away from another or when they collide, that's when earthquakes begin. If the fault between the parts is long, then the magnitude of the earthquake is great. The largest mega earthquake ever recorded occurred on May 22, 1960, in Chile. The fault was almost 1,000 miles long. It's almost half the way between Chicago and Los Angeles. And now, a similar mega earthquake can happen, underwater. That's how it all started. Last year, on August 8th, at 4:42 p.m., an earthquake with a magnitude of 7.1 occurred in southern Japan. The tremors appeared off the coast of the mainland island of Kyushu. Everyone was terrified as they expected a large tsunami to appear. But fortunately, they faced only a small wave. It collapsed on the shore, but didn't destroy buildings. About 15 people got hurt, which is sad, of course. But it could have been worse. It seemed that the disaster had passed. The residents breathed a sigh of relief. However, after that, the Japan Meteorological Agency sent a warning about a possible mega earthquake that could be incredibly devastating. A previous earthquake of 7.1 magnitude could be a harbinger of an impending catastrophe, a disaster that could affect 250,000 people. As soon as people heard this, they ran to buy groceries. Increased demand and a slight panic led to shortages of rice and several other basic products. People were stocking up on food and preparing for the worst. But a week later, the Japan Meteorological Agency canceled the warning. It turned out that the small tsunami on Kyushu Island was not a harbinger. No one knows whether a mega earthquake and tsunami will happen in this region, but the chances are very high. To understand the nature of this danger, we need to dive underwater in a place called the Nankai Trough. It is a 500-mile-long underwater fault that runs almost parallel to the Pacific coast of Japan. This is where the two giant sections of the Earth's crust meet, the Philippine Sea Plate and the Eurasian Plate. And the Philippine Plate is subducting and slowly slipping under the Eurasian Plate, on which Japan is partly located. During this movement, the plates get stuck, accumulating energy. Afterward, when they move and align again, they release a powerful burst of energy. And this energy is capable of causing one of the most powerful earthquakes in the world. Experts report that the probability of a mega earthquake and a tsunami is about 80%. Over the past 1,400 years, mega earthquakes have occurred every 100 to 200 years in this region. The last time this happened in Japan was in 1946. The entire country felt a powerful tremor that destroyed 36,000 houses in the southern part of Honshu Island. Every year, the probability of a repeat of this disaster increases by 1%. And do you know how many years have passed? 79. According to experts, a mega earthquake with a magnitude of 8 to 9 can trigger a tsunami that will flood small islands off the coast of Japan. And areas with large populations on the islands of Honshu and Shikoku can be flooded in minutes. Hundreds of thousands of people are at risk. It can be billions and even trillions of dollars worth of damage. According to some reports, about 530,000 people may lose their homes. To save lives, the country needs to carry out a large-scale evacuation. But the problem is that no one knows the exact date. In general, no one in the world can predict in advance when the next big earthquake will occur. In the case of the Nankai Trough, it can happen in a few days, or a few years, or even centuries. So, what should people do? Prepare. Japan has been experiencing earthquakes for a long time, so the country has learned to survive a disaster with minimal losses. Almost every building in Japan is equipped with dampers, which are devices that suppress any vibrations and make houses more resistant to shaking. In addition, on the shores of Japan, residents have built long and high shields that don't allow powerful waves to break through to land. Japan also has an advanced earthquake warning system. It's impossible to predict powerful seismic activity in a few days or weeks, but it's possible to detect small tremors that may portend an impending earthquake. Special devices monitor seismic signals and transmit the data to certain programs. Then, they evaluate the magnitude and intensity of the tremors and send warnings to people's phones. This can save seconds and even minutes for locals to reach the nearest shelter in time. These systems are also used to slow down the speed of trains, to stop work at factories, hospitals, and office buildings. It's much safer for a train driver to slow down during an earthquake than to rush forward at full speed. But what if you're on the street and you can't hear your phone messages? How to act in case of disaster? This applies not only to Japan, but also to any place where a tsunami or earthquake may occur. To survive a tsunami, you need to prepare for it long before a big wave hits. It's very important to have good relations with neighbors. Be friendly with them, help them, and treat them well. In times of trouble or disaster, it's great to have people with whom you have a good relationship. They can help you get out of a difficult situation, and you can also help them. Be kind and compassionate to people. This way, it's much easier to survive any disaster. Prepare a backpack with necessities in advance. These are a first aid kit, canned food, flashlights, a battery-powered radio, and bottled water. All this will not only save your life, but will also help other people in trouble. So if you feel an earthquake start, immediately run for cover. If you're at home, try to stand against a wall closest to the center of the building, or crawl under heavy furniture that stands firmly on the floor, such as a desk or a regular table. Stay away from windows and front doors, and never use an elevator. If you're on the street, don't come close to power lines and any objects that may fall. During a tsunami, you may need to get as high as possible to avoid getting swallowed by water. Stay as far away from the shore as you can, and don't go down until you're sure it's safe. But how can you find out about an approaching wave if you haven't received the warning? When a tsunami approaches the shore, you will hear a roar similar to the rumble of a passing train or plane. If there's no elevation nearby, then try to get to the upper floors. It must be at least the third floor, but it has to be a building that can resist a tsunami, such as a massive house made of concrete. If there are no such high buildings nearby, try to climb a massive tree. When the disaster is over, look around and find those you can help. Listen to messages from rescuers via radio or TV. If all is well, then you can deal with the consequences. Yes, there's a lot of work ahead, but you've survived and helped others survive. And that's the most important thing.
Hey, can you lift a truck with your hands? No? Shocker. But let me introduce you to nature's original strongman, the ocean, which casually tossed 700-ton boulders around like they were pebbles during a mega tsunami that hit Africa thousands of years ago. This wasn't just a bad day at the beach. This mega tsunami was so powerful, it made the 2004 Indonesian and 2011 Japanese tsunamis look like kiddie pool splashes. Now, to give you an idea of how terrifying regular tsunamis already are, the Japan tsunami produced waves 133 feet tall. The Indian Ocean tsunami was slightly smaller, but it took over 200,000 lives across many countries. Now imagine something way worse. You see, for a long time, scientists thought waves that big were just science fiction. But then they found these enormous boulders, massive chunks of rock, flung far inland, and did the math. It turns out only waves around 800 feet tall could have pulled off that kind of rocky vandalism. And the culprit? A volcano that literally fell apart into the ocean and triggered one of the most powerful tsunamis Earth has ever seen. Usually, tsunamis are blamed on underwater earthquakes, tectonic plates getting into slap fights. But volcanoes? Oh, they've got tsunami potential too. In 1883, for example, a volcano in Indonesia named Krakatoa erupted for 6 months non-stop until it exploded, and the explosion was heard all the way in Australia. This triggered many tsunamis, some almost 100 feet tall. Still, that was more like a toe dip compared to the full cannonball from the mega tsunami. Back in ancient times, the volcano that crumbled during the mega tsunami was huge, and it didn't just fall apart. It lost a chunk that was 10 times the size of Mount Everest. 10 Mount Everests. It was like the Earth wanted to see what would happen if we threw a mountain into the ocean just for fun. It was so massive that when the entire side of the volcano belly flopped into the Atlantic, it created waves that could cover the Statue of Liberty 3 times. It also destroyed an island more than 30 miles away. The volcano behind this real-life Michael Bay scene was called Fogo, located on, you guessed it, Fogo Island. This island is basically just a whole single volcano that rose from the sea thanks to a magma hotspot, a place in the ocean where a lot of magma escapes and erupts like an underwater volcano. Over time, this magma cooled and stacked up like pancakes until, voila, after 7 major eruptions, the island popped out of the ocean like it was playing peekaboo. Surprise, it's a volcano. But Fogo's dramatic entrance was also a ticking time bomb. You see, the more a volcano grows, the heavier it gets, and if there's not enough magma inside it to support it, the whole thing can just collapse. Sometimes it doesn't take much. A minor earthquake, some erosion, or just a poor foundation made of soft sediment can trigger a collapse. It's like a really tall guy trying to balance over a bunch of marbles. Fogo had all the bad luck ingredients: too tall, too heavy, and built on squishy ground. And it gets worse. As the volcano grows heavier, it starts squishing the magma underneath. That lava can't rise, so it just simmers down there, slowly thickening like soup left on a burner for too long. Gases build up, pressure increases, and eventually, kaboom! It's the volcanic version of eating too many burritos and then trying to hold in a sneeze. This massive pressure and imbalance can trigger what's called a flank collapse, which is science speak for oops, half the volcano just fell into the ocean. That's what happened with Fogo. Most of the volcanic islands that form this way are long gone, but Fogo is still very much alive and kicking. In fact, it last erupted in 2014, and considering that it goes off every 20 years, maybe don't travel to Fogo Island in around 2034. For the longest time, scientists believe only big, bulky volcanic islands could collapse like this. But new research says that even smaller, skinnier guys, like the Danny DeVitos of the island world, aren't safe either. The thing is that small volcanic islands only seem stable because of their small mass. It's like Danny DeVito and Arnold Schwarzenegger both slipping on the ice. Arnie's fall might cause more chaos, but Danny can still go flying. And those little collapses? Yes, they matter. Take Santa Maria, a tiny island that's about 170 times smaller than Hawaii. It has collapsed multiple times, not because it wanted to, but because it's basically standing on soggy breadcrumbs. Its foundation is loose marine sediment, and to make things worse, it's sitting right next to the East Azores Fault, where 3 tectonic plates meet up for daily slap fights. This fault is responsible for many earthquakes and even some tsunamis that happened in Lisbon in the past, so you can imagine what it's like living right above it. Every time the volcano in Santa Maria erupts and grows, it also sinks. But when a chunk collapses, it bounces back up like a buoy. This seamount to seamount to island again roller coaster means that Santa Maria has popped in and out of the ocean like a submarine playing peekaboo. And with every peak comes a potential tsunami. Another volcano with similar trust issues is Pacaya, located in Guatemala. Between 2011 and 2013, scientists spotted strange movements in the soil, tiny shifts that suggested something underneath was getting restless. Sure enough, in 2014, Pacaya erupted. Luckily, it didn't collapse, but that risk still looms, especially if magma gets trapped in it like it did with Fogo. The consequences could be explosive, literally. In fact, about 1,000 years ago, Pacaya experienced a collapse that sent debris avalanches more than 15 miles away. Since then, it's rebuilt itself like a fiery phoenix, but it could still crumble again. That's why volcanologists obsess over the tiniest wobbles. It's not paranoia if the mountain really might fall. Now you might be thinking here, okay, but that was the past. Surely that kind of ridiculous mega tsunami collapse can't happen again, right? Well, welcome to the 21st century. Islands like Hawaii, La Palma in Spain, and various parts of the Caribbean are sitting on the same kind of geological whoopee cushions. All it takes is the right combo: loose foundation, steep slopes, maybe some trapped magma, and boom, flank collapse. In fact, it's already happened recently. In 2018, Anak Krakatau, the volcanic baby of the infamous Krakatoa, lost a big chunk of itself during an eruption. It caused a tsunami, but it was more awkward than devastating, like a volcano losing its pants on stage. Embarrassing, but survivable. But that's just amateur hour compared to history's real showstoppers. Ritter Island's 1888 collapse was so intense that the island literally got shorter. It went from being more than 2,000 feet tall to a mere 460 feet. But the record holder is the legendary Latua Bay megasplash from 1958, where a 7.8 magnitude earthquake triggered a massive landslide that sent a wave taller than the Empire State Building roaring through Alaska at highway speeds. Strangely enough, only 5 people lost their lives here, but on the other hand, the destruction path it left behind can still be seen today, all the way from space. Melting glaciers and ice caps can make volcanoes collapse too. When they melt, there's a sudden decrease in pressure on Earth's crust that can destabilize entire volcanoes. It's called isostatic rebound. It's like suddenly yanking a chair out from under someone who's been sitting still for centuries. Whoops. Also, here's something you probably never thought you'd worry about on your island getaway. Some volcanic islands grow outward as lava pours into the sea, creating unstable platforms known as lava deltas. These deltas can collapse without warning, taking newly formed land, and sometimes tourists too, right back into the ocean. No pressure though, just thought, maybe you want to stay off steaming new land. So yeah, next time you're lounging on a beachy volcanic island thinking, wow, this place is paradise, just remember, it might also be a ticking geological time bomb with a flair for the dramatic. From ancient mountain-sized cannonballs to surprise lava deltas, volcanoes have a history of keeping things spicy. A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave, but the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600 before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake with an epicenter southwest of Cape St. Vincent triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor and downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with 2 more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers, because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as Tsunami Ready by UNESCO doesn't mean a community is tsunami-proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault beneath the Barents Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteotsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteotsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay safe. Earthquakes are a common thing in Japan. These natural disasters can reach a magnitude 9, where 1 is a light push and 9 can destroy entire cities. This happens because Japan is located on the Pacific Ring of Fire. It's like this. The entire surface of our planet is broken up into about 12 large pieces of the Earth's crust, and they're all moving slowly. In those places where these pieces meet, earthquakes occur most often. Japan is just at the point where the Pacific Plate collides with the plate of the Philippine Sea. This collision happens underwater and creates huge waves, and it could be much worse than just an earthquake. To escape from the water disaster, people built huge walls along the entire northeast coast. Not every earthquake provokes a tsunami. Many tremors occur when the Earth's crust diverges in different directions and creates gaps. It can destroy houses, streets, and forests, but such an underwater earthquake can't cause a tsunami. Huge waves are formed only when seismic activity causes the crust to move vertically up or down. The water pressure shifts at the very bottom, which generates a release of energy. This energy pushes the water and creates a tsunami. By the same principle, you can start little waves when you throw a stone into the water, and such vertical earthquakes often occur off the coast of Japan. First, a wave forms. It's gaining speed and increasing in size. Its height can reach about 40 feet, almost as tall as a 5-story building. It's approaching the coast and accelerating to 500 miles per hour. This is about the cruising speed of a commercial airliner. Millions of gallons of water weighing thousands of tons are getting closer. And now the wave is reaching the shore and demolishing everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. A tsunami that was that strong covered the northeast coast of Japan in 2011. It changed the landscape of the beach and the seabed. These changes are the reason for another dangerous natural phenomenon: underwater vortices. Whirlpools draw in everything that is nearby. They used to build dams along the coastline to protect coastal villages, but the wave force easily destroyed these walls. That's why, after the disaster of 2011, they decided to create new large-scale protection in Japan. They spent more than $10 billion in several years on it. As a result, they created about 440 massive walls all along the coast. They combined these sections into one large dam, almost 250 miles long and 45 feet high. The construction is supposed to protect the coast against strong tsunamis, but still, the government has moved some coastal villages to higher terrain. They also ban building anything by the shore. Despite the protection it gives them, many locals aren't happy with the wall. It's a huge problem for the fishing industry. The wall blocks access to the ocean, so ships and boats can't dock at the shore. Some people are unhappy that their windows now face the concrete wall instead of the blue ocean. The money spent on the wall could have been spent on moving even more houses. Residents have concerns the wall only creates an illusion of security. A giant wave can crash into it at great speed and break it into pieces. And these concrete parts can cause even more destruction. Some scientists agree with this opinion. Most experts aren't sure the wall won't give 100% protection, but it can help delay the flood, giving people more time to evacuate. In such situations, every minute counts. It's impossible to predict the earthquake occurrence accurately. But when it starts, the sensors can calculate how much time it would take for the wave to arrive at the shore. For example, the last time a tsunami warning was given 5 minutes after the earthquake. Any big wave is moving at great speed and may be very close to the shore. It seems people almost don't have time to save themselves from a tsunami. Fortunately, the citizens of Japan are ready for this. They regularly take part in tsunami evacuation drills. They learn how to act correctly during a coming flood. They have a plan of action that can save their lives. All that, along with the wall, increases the chances of surviving a catastrophe. Not only tsunamis are formed around the shores of Japan, the power of water here often meets the power of fire. In 2010, a few hundred miles south of Tokyo, near the island of Iwo Jima, a heavy low rumble came from the depth of the sea. Then 1 million bubbles moved to the surface. The water started heating up and boiling. Its temperature was so hot that you could poach eggs in it. The hot area grew to the size of a stadium. All this was accompanied by a huge amount of superheated steam filling all the air around. Then pieces of soil came out from the water. At this point, it was all over. The water cooled down, the ocean surface became calm again. On that day, an underwater volcano erupted. No catastrophe occurred, but in 2021, this happened again. Japan's Coast Guard warned of strong volcanic activity in the region. Hot steam and gases from the volcano's mouth burst out of the water and rose into the air to a height of 10 miles, which is about twice as high as the top of Mount Everest. A huge volcano woke up and began to rise slowly from the surface. If you look at this place from above, you can see that it's not just a volcano, it's a whole island shaped like a horseshoe. Seismologists say this volcanic island is just the tip of the iceberg, as they mix their metaphors. There is still a lot of volcanic space under the water. The island fills the air with gas and ash. The sky turns gray. Scientists continue to monitor the volcano, but they don't know what consequences this may lead to. Such eruptions of underwater volcanoes are not uncommon off the coast of Japan, but the event itself is unique. Underwater volcanoes don't explode and don't release lava flows upwards. A huge amount of water above them creates high pressure. As soon as the magma gets out, the water immediately presses it to the seabed. Millions of gallons of lava sink, cool down, and solidify around the volcano. This lava forms a thick layer of Earth's rock. Most underwater eruptions don't cause any changes on the ocean surface, but to make an island appear on the surface, a volcano needs a lot of magma. The next volcanic eruption creates another thick layer of it. Millions of years pass, and flows of lava form mountains. Constant eruptions increase the seabed height. Layer by layer, the cooled lava rises higher and higher, and then one day it appears on the surface and turns into an island. So, in 2013, a small piece of land appeared next to an existing island. Emerging from the water, the volcano began to grow slowly and eventually connected with the island. The area of this island increased by 12 times after 2 years. Vapor is always pouring out of this island, and its surface is filled with super hot lava flows. The volcano behaves unstable, and nobody knows when it's going to calm down. Once, people built a small town on a similar island. This place still exists today. It's located south of Tokyo and is called Aogashima. People are not too worried about the possibility of a catastrophe, despite the fact the last time a volcano erupted here was in May 1785. I wasn't around then. By that time, people had already built a city and lived there. Then, one sunny day, thousands of birds suddenly took off and left the island. Then the ground began to shake. A heavy, low sound came from the island depths. Streams of gas rushed from the top of the overgrown forest volcano. The volcano threw dirt and large stones into the sky. The eruption wasn't quick. It lasted several weeks. More than 200 years have passed since then, and the volcano is still sleeping. They rebuilt the city. Now this place looks like a dream. That's probably the reason why people don't want to leave it. Despite the risk of a new eruption, they continue to live and work here. There are many thermal springs. The island also has rich soil, and the waters around are full of fish. The volcano may wake up at any moment. Fortunately, meteorological and seismological services monitor the volcano activity. So, any guesses? An underwater earthquake opens a huge gap in the ocean floor. A large volume of water moves to fill the crack. At the same time, waves start to spread out from that point. They're just a foot high at first, but the closer they get to shore, the larger they become. When the waves reach shallow waters, they start to slow down. Their lower parts get to dry land first. This creates a vacuum effect that pulls the water away from the coast. The harbor and seafloor are visible now. And then, an enormous wall of water hits the shore. It wipes out everything in its path. Several minutes later, more waves usually arrive. Or it can be a landslide happening near a large body of water. Enormous amounts of forest, soil, and rock roll down into a lake or ocean, producing huge tsunami waves. Volcanic eruptions are responsible for 5% of the world's tsunamis. They can move great volumes of water and generate really big waves. Some tsunamis are caused by meteorites striking into our planet. If one of these red-hot space visitors strikes the ocean, the force of this collision displaces enough water to produce an extremely powerful tsunami. When a tsunami starts, its waves are usually just 1 foot high. That's what a small wave looks like. It comes up to the waist of the average person. Surfers call such rather big waves double overhead. The largest earthquake ever recorded happened near the coast of southern Chile. It triggered a tsunami that reached Hawaii, Japan, and the Philippines. The tsunami's largest wave was as tall as a 5-story building. The largest wave ever surfed was half as tall as the Arc de Triomphe in Paris. Garrett McNamara set this record in 2011 in Nazaré, Portugal. In 1995, scientists proved the existence of rogue waves, sudden unexpected swells. On that day, they saw an 84-foot wave. It was taller than the world's largest passenger plane Airbus A380. The giant was surrounded by smaller 20-foot waves. Tohoku tsunami waves in 2011 were generated by the strongest earthquake in Japan's recorded history. The highest wave was almost half as tall as the Brooklyn Bridge. Krakatoa's volcanic eruption in 1883 produced the loudest sound ever heard on the surface of the planet. The highest tsunami wave the eruption formed was as tall as the Statue of Liberty. April Fool's Day tsunami in 1946 was triggered by a powerful earthquake near Alaska. The tsunami's highest wave was a bit taller than the Colosseum in Rome. The Boxing Day tsunami started in the Indian Ocean in 2004. It was caused by a powerful undersea earthquake. Its tremors produced a series of tsunami waves. The largest of them almost reached the height of the Leaning Tower of Pisa. One of the most disastrous landslides hit Lodeland Valley in Norway in 1936. An enormous piece of rock, almost twice as large as the Eiffel Tower, broke loose and hurtled into Lofoten Lake. This caused an enormous tsunami wave. It was almost as tall as the Taj Mahal in India. 2017 Greenland megatsunami was triggered by a massive landslide at one of the fjords. The waves that flooded the shore reached the height of Big Ben. A powerful volcanic eruption caused a landslide from a 4,000-year-old lava dome. This set off Unzen volcano mega tsunami. The largest wave was half as tall as the Space Needle in Seattle. Fogo mega tsunami happened 73,000 years ago, when a part of the Fogo volcano collapsed into the sea. The mega tsunami's largest wave was as tall as the Washington Monument. When the upper 1,500 feet of Mount St. Helens exploded, it caused a massive landslide. A part of this avalanche plunged down into Spirit Lake. This caused a wave that was more than half the height of the Eiffel Tower. The Vejont Dam mega tsunami happened when a landslide dragged 9 billion cubic feet of forest, soil, and rock into the lake. A colossal wave overtopped the edge of the dam, taking out everything in its path. Its height was greater than that of the Golden Gate Bridge. A landslide in Lituya Bay in Alaska formed a megawave, one of the largest ever recorded. The mega tsunami surged over the headland, washing away trees, plants, and soil down to bedrock. The wave reached more than half the height of the Burj Khalifa, the tallest construction in the world. A third of the East Molokai volcano in Hawaii caved in and collapsed into the Pacific Ocean. This created a tsunami the size of the second tallest building in the world, Shanghai Tower. There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai Trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gerwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
On January 26, 1700, one of the biggest earthquakes in history hit off the coast of the United States. It had a magnitude of 9, which puts it in the top 10 most powerful earthquakes ever recorded. This earthquake triggered a huge tsunami and changed the coastline all the way from southern British Columbia down to northern California forever. Back then, the area wasn't very populated, but thanks to some clever research, scientists figured out exactly what happened that day by looking at old geological records, tree rings, and even some history from Japan. On the same day as the earthquake, a massive tsunami also hit Japan's eastern coast. For a long time, no one connected the two, but in the 1980s and 90s, researchers realized the tsunami in Japan had been caused by the earthquake in the Pacific Northwest. They were also able to pinpoint the exact day, January 26, 1700. They even found old trees in coastal Washington that had all perished around the winter of 1700, which matched up perfectly with the timing of the earthquake. The earthquake came from the Cascadia subduction zone, a fault where the Juan de Fuca plate slides under the North American plate. This fault stretches about 700 miles, from northern Vancouver Island in British Columbia to Cape Mendocino in California. The pressure from the moving plates builds up over time, and eventually, another big, devastating earthquake will hit the same region. It's just a matter of time. By looking at the geological records, past tsunami deposits, and signs of land level changes, scientists can figure out how often these huge earthquakes happen. Emergency planners have been preparing for the next big quake, often calling it the big one. Scientists believe earthquakes in the Cascadia subduction zone happen every 200 to 1,000 years. And since the last major one was over 300 years ago, the Pacific Northwest is definitely due for another. When it happens, the earthquake is expected to be as big as the one from 1700. But this time, it'll affect around 15 million people. The devastation will be severe. Buildings will collapse, roads and runways will crack, and bridges will fall. Communication in and out of the area will be cut off. But the worst part? The earthquake will trigger a massive tsunami that might hit parts of the Washington coast in as little as 10 minutes. It's not a matter of if, but when the Cascadia subduction zone will break. When it happens, it will be the worst disaster the US has ever faced. Worse than the Hurricane Katrina or Superstorm Sandy. It'll impact an enormous area, stretching from southern British Columbia all the way down through Oregon to northern California. That means millions and millions of people will be affected. Fairchild is considered a backup staging area for handling the aftermath of the earthquake, with Grant County International Airport in Moses Lake being the main one. For those who will survive the initial quake and tsunami, the aftermath could be just as disastrous. Aftershocks will follow, and transportation will be a mess. Roads will be damaged or completely blocked, airports will shut down, and most of the main routes, like Interstate 5, will have bridges destroyed. This means food and water supplies will be cut off, and it will be incredibly difficult for help to get in or for people to escape. Gas pipelines will most likely be damaged too, and restoring them could take anywhere from a few days inland to weeks or even months along the coast. Power outages will be widespread within 100 miles of the coast throughout the entire Pacific Northwest. And water could be out for 3 to 7 months. Even telecommunications will be down for 2 to 3 months across the Pacific Northwest, Alaska, and even parts of East Asia. The good news for eastern Washington is that it will mostly avoid the worst of it, thanks to natural barriers between the west and east sides of the state. The tsunami may hit the Columbia River Gorge, but it will lose energy quickly because of a sandbar under the river. The Cascade Mountains will absorb much of the earthquake's impact, so the east side won't feel it as strongly. And since eastern Washington won't get hit as hard, it'll be up to them to handle the aftermath of the quake. That means helping western Washington, taking in refugees from the areas that got destroyed, and delivering supplies to where they're needed. Scientists have looked at other major 8.0 to 9.0 magnitude earthquakes like the ones in Chile in 1960, Alaska in 1964, and Sumatra in 2004, and Japan in 2011. These kinds of quakes can shake the ground for anywhere between 6 to 10 minutes, and that's a long time for the ground to be shaking. Such quakes are super intense because they happen close to Earth's surface, so it's not just a quick shake. It's a long, strong one that can cause a lot of damage. If the Cascadia earthquake and tsunami were to hit tomorrow, over 13,800 people could lose their lives, and about 107,000 people could be injured. The economic toll in Washington, Oregon, and California could top $70 billion. To put that into perspective, we can compare these numbers with some other major earthquakes. In Chile's 1960 earthquake, about 1,650 people lost their lives. The 1964 Alaska quake resulted in around 140 lives lost. The 2004 Sumatra earthquake and tsunami took the lives of an estimated 280,000 people. And the 2011 Japan earthquake and tsunami caused over 20,000 casualties. Authorities know about the dangers of the Cascadia fault, but even with all the planning, no one can say for sure what will be needed when the big quake hits. Right after the earthquake and tsunami, the areas outside the immediate disaster zone won't be able to help much because roads and airports will be destroyed, and resources will be limited. How can we deal with this kind of disaster and its effects? We don't have all the answers yet. Right now, let's focus on the Cascadia subduction zone. It's a huge fault line that stretches about 620 miles from Vancouver Island to Cape Mendocino in California, sitting about 93 miles off the coast. It's like one tectonic plate is slowly sliding under another. When the plates are close to the surface, about 18 miles deep or less, they get stuck because of friction, kind of like pushing two rocks together. Over time, this creates a lot of pressure. When the pressure finally becomes too much, the plates slip, causing a massive earthquake. This is called a megathrust earthquake, and it can be huge. Below the area where the plates are stuck, there's a zone where the plates move really slowly. We're talking about just a few inches every few months. This slow movement helps to release some of the pressure, but it also builds up more pressure on the parts of the fault that are still stuck. This means that over time, it increases the chances of a huge earthquake happening. These massive quakes, called Great Subduction Zone earthquakes, can be stronger than magnitude 8.5. Megathrust earthquakes are the biggest earthquakes that happen. They can go over a magnitude of 9.0, which is insanely powerful. Just to put it in perspective, a magnitude 9.0 earthquake releases 1,000 times more energy than a 7.0 and 1,000,000 times more energy than a 5.0. These earthquakes happen when a lot of pressure builds up in a part of the fault that's locked, which means the plate can't move past each other. When that pressure gets too high, the fault finally ruptures, releasing all that built-up energy in one massive shake. The Cascadia subduction zone is super long. That's why if it were to rupture all at once, it could produce a large earthquake. Scientists have studied this region and found that about 18 miles below the surface, the fault is completely locked. The plates there aren't sliding past each other. But deeper down, the plates start to slide more smoothly, causing less friction. This is important because it tells us how much stress is building up in that locked zone, and how it could eventually lead to a major earthquake.
Before an earthquake shakes the ground, something sneaky might happen first. A slow, quiet movement with no shaking at all. No one is aware that right under their feet, the land is preparing to tremble violently, wreaking havoc, bringing destruction and devastation. A new study shows that such a slow creep might be how earthquakes begin. To figure this out, scientists didn't start with giant pieces of the Earth. Instead, they went into a lab and used clear plastic sheets called plexiglass. They pushed two sheets of plexiglass sideways against each other, just like how tectonic plates, huge chunks of Earth's crust, push against each other underground. As they pushed, the plastic cracked, kind of like what the Earth does during an earthquake. And even though it was plastic and not rock, the physics, the way things break and move, was the same. Earthquakes happen when two tectonic plates try to slide past each other, but they get stuck. The edges between them don't move easily because of something called friction. It's kind of like when your shoes grip the ground. Over time, the plates keep trying to move and stress builds up. Think of it like bending a stick. At first, it doesn't break, but if you keep pushing, it will eventually snap. The spot where the plates are stuck is called a fault, and there's a thin brittle part in that fault. By brittle, I mean that it doesn't bend, it just breaks. Here's how it happens. First, a tiny crack forms. It's small and moves slowly. There's no shaking yet, but something is already happening under the surface. The crack spreads, building up more energy. When it finally reaches the edge of the brittle zone, boom, it speeds up, suddenly racing forward really fast, almost as fast as sound, and that's when the Earth starts to shake. So scientists decided to find out how that very first crack starts. They conducted their experiment, whose setup was similar to a type of fault in the real world called a strike-slip fault, like the San Andreas Fault in California. Even though the materials, plastic versus rock, are different, the way cracks form and move is exactly the same. The experiment has helped scientists understand that earthquakes don't always start suddenly. Sometimes there's a slow, quiet start, like a warning sign before the big quake. This early stage of an earthquake is called a nucleation front. It's like a seed of a crack, gently creeping through the material long before any actual rupture happens. This quiet and slow movement doesn't release energy into the surroundings. At first, scientists thought of cracks as simple one-dimensional lines, like a straight tear in paper. But something didn't add up. The slow-moving nucleation front wasn't behaving like a normal, fast-moving crack, and it wasn't clear why or how it suddenly sped up and became an earthquake. The answer came when scientists realized they had to think in two dimensions instead of one. Instead of imagining the crack as just a fine line, they began to think of it as a patch, like a growing circle, that starts at the surface where two materials touch. As this patch spreads out, more material along its edge has to break. The important thing here is that the energy needed to break the material is related to how long the patch's edge or perimeter becomes. The bigger the perimeter, the more energy it takes to keep breaking. That's why this patch moves slowly at first. It doesn't yet cause the violent shaking we associate with an earthquake. Because it moves without sending shaking waves, this stage is called aseismic. Eventually, the growing crack patch spreads beyond the special brittle zone, where the materials are stuck. Outside this zone, the energy needed to keep breaking the material doesn't increase anymore. Instead, there's now extra energy building up, more than what's needed to keep the crack growing slowly. This extra energy doesn't stay quiet. It suddenly powers the crack to move much faster, turning it into a full-speed rupture. That's the moment when the earthquake begins and the ground starts to shake. These findings help explain how earthquakes might start off slow and silent before quickly turning dangerous. They show that small, slow cracks can suddenly transform into powerful, fast-moving ruptures if the conditions are right. Scientists believe that they can learn to detect the aseismic stage before a crack speeds up. It might one day be possible to predict earthquakes, or at least understand the warning signs better. Now, even though earthquakes are only the third most common type of natural disaster, they cause the highest number of fatalities. NASA plays an important role in studying earthquakes by using satellites that orbit the Earth. These satellites collect data and images that show how the ground changes after an earthquake. For example, they can detect when the land shifts, rises, sinks, or cracks. These surface changes help scientists learn more about the strength and impact of earthquakes. NASA's satellites can also track changes in nighttime lights. If a city goes dark after a quake, that's a clear sign that the area may have lost power and could need help. Now, how about we talk about the most common earthquake myths, like the one about megaquakes? Some people really worry about super huge earthquakes, but there's a limit to how big they can get. The size of an earthquake depends on the size of the fault where it happens. A longer and deeper fault can cause a bigger earthquake. For example, the San Andreas Fault in California is long, about 800 miles, but not very deep, around 10 to 12 miles. This makes earthquakes bigger than magnitude 8.3 on that fault very unlikely. The biggest earthquake ever recorded happened in Chile in 1960. It had a magnitude of 9.5 and occurred on a huge fault that was almost 1,000 miles long and 150 miles wide. Technically, there's no set limit on the magnitude scale, but an earthquake bigger than magnitude 12 would need a fault larger than Earth, which just isn't possible. Now, earthquakes can happen near the surface or deep underground. Most occur in Earth's crust or upper mantle, down to about 500 miles deep. But the deepest ones happen only at subduction zones, places where one part of Earth's crust slides under another. In California, almost all earthquakes happen in the top 15 miles of the crust. One exception is the Cascadia subduction zone in Northern California, which continues up through Oregon, Washington, and Canada. Another misconception is that the ground can open during an earthquake, but usually that only happens in movies. A giant crack opening and swallowing things up during an earthquake is just fiction. In real life, the ground on either side of a fault slides past each other. It doesn't pull apart or open wide. Small cracks or holes can happen during landslides or ground failures, but not along the actual fault line itself. Faults don't open up because if they did, there'd be no friction, and without friction, there wouldn't be an earthquake at all. Now, some people think California could break off and sink into the ocean during an earthquake, but that's not how it happens. The ocean floor is just lower land with water above it. California can't fall in. What's really happening is that southwestern California is slowly sliding north toward Alaska along the San Andreas Fault. The Pacific Plate, which California sits on, is moving about 2 inches per year, about as fast as your fingernails grow. So, in about 15 million years, Los Angeles and San Francisco could be neighbors. And in 70 million years, Los Angeles might be sitting near Alaska. I can't wait. People often wonder whether an aftershock can be bigger than the earthquake itself. Aftershocks are smaller earthquakes that happen in the same area after a larger one. They're like our planet's way of settling down after the main shock. But if an aftershock turns out to be bigger than the first earthquake, then we call the bigger one the main shock, and the earlier one becomes a foreshock. About 5 to 10% of earthquakes in California are followed by a stronger one within a week. It's also possible for two quakes in the same area to be about the same size. However, very large earthquakes are rare, so it's even rarer to see two huge ones happen close together.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the fifth largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the fifth largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground. But there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of three main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault Line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas Fault Line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tejon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something it can cause more damage than the big one. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put two and two together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed. But Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves in earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. you hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and… whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city. Get ready, because one of the Pacific Ocean's most active volcanoes might blow any minute now. Scientists monitoring axial seamount, a gigantic underwater lava factory just off the coast of Oregon, say it could erupt literally any time between today and early 2026 at the latest. Yes, it's underwater, but don't get tricked by the ocean's cover. This beast is almost 3 times taller than the Empire State Building. This volcano is inflating like a souffle at a Michelin-starred restaurant, and scientists are so excited they will live stream it. Seriously! So, here's the thing. This volcano will explode at any moment now because, well, it's inflating fast. Over the past few months, researchers have noticed that the seafloor is literally rising. It's like Axial is doing its best impression of a waterbed filled with molten rock. Scientists call this inflation, which sounds like something you'd complain about after Thanksgiving dinner. But in volcano terms, it means magma is piling up underground, causing the seafloor to bulge like a souffle that's this close to collapsing. Now, an underwater volcanic eruption might not sound so exotic. After all, most volcanic activity on Earth happens under the sea. Believe it or not, there are more than 1 million submarine volcanoes quietly churning lava beneath the waves as you watch this. The ocean floor is Earth's biggest volcanic hotspot. What makes axial seamount so thrilling is that it's under intense scientific surveillance, unlike any other underwater volcano. It's like the star player in a volcanic reality show, with a network of ocean-bottom instruments giving researchers real-time updates on magma movements, seismic tremors, and crust deformation. In fact, axial seamount hosts the world's first-ever underwater volcanic laboratory. Scientists have been keeping a constant eye on it since the 1990s, when they installed sensors that now relay live data straight from the seafloor. This kind of monitoring is unheard of elsewhere and has turned Axial into a geological celebrity, one whose behavior we can track with remarkable precision. Besides, Axial is hilariously predictable. It erupts roughly every decade, and right on cue, it's gearing up for another performance. By mid-2024, it had inflated to nearly the same level as before its last eruption, which means the countdown is on. Scientists are so confident in its schedule that they've set up a volcanic advent calendar, waiting for the day when Axial decides to pop. But hold on, axial seamount isn't just your average underwater volcano. It's got style, personality, and a geological identity of its own. Now, most underwater volcanoes, called seamounts, tend to look like cones or flattened domes. Axial laughs in the face of tradition with its unfashionably rectangular caldera, a 2-by-5-mile crater that looks like it was designed by a geologist with a ruler and a grudge against curves. Most volcanoes opt for the classic circular look, but Axial, it went full avant-garde. This caldera is punctuated by fissures, vents, lava channels, and mysterious dome-like structures that rise hundreds of feet high. It's like the volcano's wearing a funky geometrical crown instead of the usual rounded hat. What's more, Axial's location is like prime real estate for geological fireworks. It sits right where two major forces collide, literally. First, it's on the Juan de Fuca Ridge, an underwater mountain range formed where two tectonic plates are slowly pulling apart, like a zipper being undone. Second, it's perched atop the Cobb Hotspot, a deep mantle plume that acts like Earth's sneaky magma espresso machine, pumping molten rock from deep inside the planet and fueling a whole chain of seamounts. To put it plainly, it's like the tectonic plates are reluctant dance partners, sliding away from each other, while the Cobb Hotspot acts as the DJ, turning up the heat and keeping the magma party going. This dual influence creates a complex plumbing system inside the volcano, with magma chambers filling, draining, and shifting in ways scientists are still trying to decode. The competition between the spreading plates and upwelling magma is what gives Axial its unique geological fingerprint, and it's also why this volcano keeps surprising us. Now, we said that Axial Summit isn't just a crater. The truth is that inside, the action gets even weirder and cooler. Well, hotter, but you get it. Axial hosts black smoker hydrothermal vents, which blast superheated water at temperatures exceeding 700 degrees Fahrenheit. This is no ordinary underwater hot tub. These vents create one of Earth's most extreme environments, where bizarre creatures thrive in total darkness and scalding heat. Giant tube worms, crabs, colonies of bacteria, and even octopuses live off the mineral-rich plumes that gush from these vents, forming ecosystems completely independent from sunlight and photosynthesis. It's like an alien world beneath the waves, thriving off the volcano's fiery breath. These vent communities are crucial to science, not just because they're strange, but because they may resemble the earliest ecosystems on Earth. Some researchers believe life on our planet may have originated in similar deep-sea hydrothermal environments billions of years ago. Studying them could also help us search for life on icy moons, like Europa and Enceladus, where similar vents might exist beneath their frozen surfaces. When Axial erupts, It's like a natural reset button for these communities. The lava wipes everything out, but within months, life comes roaring back. Proof that even in the most hostile environments, real estate is always in demand. For those worrying about tsunamis or coastal disasters, relax. Axial's eruptions are the underwater equivalent of a slow cooker. The immense water pressure keeps things chill, well, scalding, but not explosive. So the worst thing that happens is some lava decorates the seafloor, and a few crabs have to find new vents to squat in. This means no massive ash clouds or explosive blasts that could reach the surface. Instead, lava oozes out and spreads across the seafloor, sometimes traveling for miles. But for scientists, this eruption is the golden ticket. Understanding Axial's patterns could help predict eruptions elsewhere, even on land. Plus, its bizarre ecosystems offer clues about how life might survive on other planets. Not bad for a volcano that mostly just sits around looking rectangular. Still, the volcano's activity can be heard in the form of thousands of small earthquakes every day. Thousands! As if the volcano itself was groaning and creaking, preparing to burst open. Again, we won't feel a thing, but at least they'll help scientists track the magma's movements and the volcano's eruptive cycle. Now, one of the coolest parts of this story is that scientists are preparing to live stream Axial's next eruption for the first time ever. Imagine watching an undersea volcano in action, live, as it's painting the ocean floor with fresh lava. It's like a front row seat to a natural fireworks display, thousands of feet beneath the waves. The livestream will come courtesy of the Ocean Observatory's initiative, which maintains a series of fiber optic cables linking Axial's instruments directly to shore. It's the Wi-Fi of the deep sea, and it's about to broadcast molten rock in HD. And there's another twist. Scientists have noticed a curious pattern in Axial's eruptions. All three of its most recent eruptions, in 1998, 2011, and 2015, happened between January and April, the months when Earth starts moving away from the Sun. So why? Well, it might have something to do with the Moon's gravitational pull. The Moon's orbit causes ocean tides to rise and fall, which changes the pressure on the seafloor and could help nudge the magma chamber to its breaking point. I guess the Moon isn't just a romantic light in the night sky. It might be the ultimate volcanic whisperer. So, one thing's for sure, when Axial goes, it'll be the best documented underwater eruption in history. So, keep your eyes peeled. This is one natural spectacle you won't want to miss. And who knows, if we're lucky, we might even get deep-sea eruption ASMR out of the deal. Now, if you'll excuse me, I'll be refreshing the live feed like it's a Taylor Swift ticket sale.
At first, researchers thought their cameras were glitching. It was the only possible thing that could explain the weird view in front of them. Scalding water was blasting upward while cool methane was fizzing out right beside it. Such a combo wasn't supposed to even exist, but it did. Scientists were exploring the ocean floor near Papua New Guinea when they stumbled across a weird deep-sea hotspot. It wasn't like any other hotspot. There, super hot and cool methane-packed gas were bubbling out almost side by side. This almost never happens in nature, so the researchers were pretty shocked. They were cruising around with a deep-diving robot, the Rove Keel 6000, poking around underwater volcanoes in a remote island chain. These volcanoes hide all sorts of strange features, but nobody expected to find a full-on hydrothermal vent just tucked down there. Plus, other research trips had passed through the area before and missed it completely. This time, the robot's cameras lit up the seafloor and revealed a bizarre view: boiling vents and cold gas seeping out of the seabed. They were practically touching each other. As you understand, normally these two things show up in totally different places. Hot hydrothermal vents form when underground water gets cooked by magma and shoots upward, carrying minerals with it. Methane seeps, on the other hand, come from cold, mushy layers of sediment packed with old organic matter. This stuff slowly breaks down and leaks out as gas. But at this spot, the geology created a perfect mashup. Under the volcano sits a thick layer of organic-rich sediment. Magma creeping up from below heats these sediments, but at the same time, it also heats mineral-rich water deeper down. So you get two very different fluids, blazing hot vent water and cooler methane gas. Still, both are traveling upward through the same cracks in the seafloor. When they reach the surface, they escape just inches apart. So you end up with this bizarre little neighborhood where boiling mineral water and chilly methane bubbles are hanging out like best buddies. To ocean scientists, this is like discovering a unicorn that can also fly. It's weird, rare, and super exciting. An even more exciting thing is that right next to those weird hot and cold vents, an entire mini world of creatures has taken over the rocks. The place is packed with huge clusters of deep-sea mussels, long tube worms, little shrimp, and amphipods crawling everywhere, and even bright purple sea cucumbers sitting out in the open. The animals are so crowded together that it's hard to even see the rock underneath. Scientists are pretty sure some of these creatures are totally new to science, but they need a special trip just to identify everything living there. The strange mix of hot fluids and methane-heavy gas also changes the rocks themselves. The methane down there is super concentrated, while hot water coming from deeper inside the volcano brings chemicals with it. Together, they create unusual reactions underground. Because of this, metals like gold and silver have built up in the rocks, along with elements like arsenic, antimony, and mercury. It's like a chemical time capsule. The rocks show signs of an older, super hot phase when precious metals were forming. Today, the vents are cooler, but still active. Now, even though this deep sea area is rare and full of life, it isn't safe. Mining already happens nearby, and waste from the huge gold mine on Lahir gets dumped into the ocean. On top of that, companies have licenses to explore the seafloor for minerals and gas. All of this puts the fragile vent community in danger because many of the animals here can only survive in these exact conditions. So scientists are urging for more research and strong protection plans before this one-of-a-kind ecosystem is damaged beyond repair. This underwater treasure needs to be saved before industry wipes it out. This discovery, though, isn't the only unique ecosystem we've ever found. In January 2025, a gigantic iceberg named A84, roughly the size of Chicago, cracked off Antarctica's George VI ice shelf. This ice shelf is enormous on its own, stretching about 280 miles from end to end and about 820 feet thick. During the Antarctic summer, which is November through late February, the top of the ice shelf melts and forms long, skinny pools called ribbon lakes. They got that name because they really do look like giant icy ribbons stretched across the surface. Once A84 broke free and drifted off, it exposed part of the seafloor that had been sealed away under the ice for who knows how long. It was a place absolutely nobody had seen before. A research team aboard the ship Falkor 2 happened to be in the Bellingshausen Sea at the time. As soon as they got word about the iceberg breaking loose, they ditched their original plan. This was basically the deep-sea version of flipping over a huge rock in the woods just to see what's living underneath it. For 8 days, the scientists sent down their underwater robot, Sebastian, and explored depths of more than 4,200 feet. Down in that freezing darkness, they discovered a hidden ecosystem packed with life. Huge corals and sponges formed underwater neighborhoods that were absolutely crawling with creatures. They were not just barely alive, they were thriving. So yeah, the scientists expected to find something down there, but they definitely didn't hope to spot a full-on underwater city of ancient life. There were sea anemones that looked like tiny fluffy trees, sea spiders marching around like creatures from other planets, ice fish, octopuses, and a whole mix of other animals. The entire expedition was live-streamed to researchers around the world. By the way, the recordings are still publicly available if you're interested. Even cooler, the researchers think some of the creatures they saw might actually be brand new species. That's right, genuinely new species in Antarctica in 2025. A few might live only in this one area, and that makes sense because Antarctica is basically its own isolated planet. It's surrounded by the Antarctic Circumpolar Current, which acts like a giant watery moat that has kept the continent cut off from the rest of the world for millions of years. But even if the new species ended up being known ones, the scientists still found some extremely rare animals, like tiny snails, bristly worms, aka polychaetes, little crustaceans, and even the mysterious phantom jellyfish, which already looks like something from outer space. The scientific name for the phantom jelly is Stygiomedusa gigantea, but no one really needs that mouthful, so giant phantom jelly is fine. This thing is massive. Its bell, the umbrella-shaped top, can be more than 3 feet wide. It also has 4 long ribbon-like arms that can stretch up to 33 feet. That's the length of a school bus. Actually, the first one was collected in 1899, but scientists didn't even realize it was a completely new kind of jellyfish until 60 years later. Its body is mostly see-through with a ghostly purple tint, and instead of normal tentacles, it uses those big flowing arms to grab prey and feed itself. Even though jellyfish don't have brains, the way this giant phantom jelly moved caught scientists off guard. It seemed to steer its long arms with surprising control, especially when it drifted through tight spaces near the seafloor. It looked cautious and almost intentional, which is kinda unsettling. Another maybe kinda sorta smart creature lurking in the dark ocean? Great. The researchers also found bristleworms. Officially, they're called polychaetes, but bristleworms sounds way more fun. These worms are common in cold, deep oceans and come in tons of shapes and sizes. Their bodies are made of segments lined with tiny bristles that help them crawl, sense the environment, and defend themselves. One standout is the Antarctic scale worm, which has shiny golden bristles that make it look surprisingly fancy for a creature living in freezing darkness. So, as you see, there are still tons of places and things on Earth that don't seem real or aren't even supposed to exist. And even with our level of technology, we're unlikely to figure out all the wonders the world has to offer in the near future. The floor is lava! Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate. a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first. While you're watching this video, pieces of continents are slowly breaking off from below and are pulled down into the oceanic mantle, a hot, mostly solid layer that moves slowly under the seafloor. As soon as these fragments reach the mantle, they can trigger volcanic eruptions in parts of the ocean where there are no volcanoes. Plus, when continents break apart, it happens not only at the surface, but also deep down. But more on that later. This process can continue for tens of millions of years. The new study shows that Earth's insides are even more dynamic than we thought. It also explains why many volcanic islands, including Christmas Island in the Northeast Indian Ocean, contain unusually high levels of certain chemical elements. The thing is, these elements are normally only found in continental crust. Well, scientists did suspect that these elements showed up because some powerful forces deep inside the Earth took old, recycled pieces of rock and mixed them into the mantle. This process works a bit like when you mix together ingredients for cake batter. But before, researchers believed those elements came from two main sources: sediment that sank into the mantle as oceanic plates got pushed down, or from mantle plumes. Those are columns of hot rock rising up from deep inside Earth. However, these explanations don't fit all observations. In some volcanic areas, there's almost no sign that the crust has been recycled. In other places, the mantle seems to cool and too close to the surface to be affected by the rising hot rock. Scientists used to wonder how this could happen. Now we know that some of the material in those regions comes from pieces of continents that sink deep into the mantle, and these pieces affect the volcanoes that form above. The new study also suggests a curious idea. Continents don't just break apart at the surface, they peel away from below too. And this can happen over much greater distances than scientists thought before. Researchers used simulations to figure out how continents and the mantle behaved when stretched by tectonic forces. Their work is built on earlier research showing that when continents split, deep, powerful forces inside our planet create a mantle wave. This wave moves along the base of the continent at depths of about 90 to 125 miles. The wave moves extremely slowly, about a millionth of the speed of a snail, and gradually strips material from the roots of the continents. These peeled-off fragments are then carried sideways, sometimes more than 620 miles, into the oceanic mantle. Once there, they can trigger volcanic eruptions in the ocean for tens of millions of years. The research also shows that the mantle continues to feel effects of continental breakup long after the continents themselves have separated. Even after a new ocean basin forms, the mantle keeps moving, reorganizing and transporting enriched material far from where it originally came. To make this conclusion, researchers studied geochemical data from different parts of the Earth, including the Indian Ocean Seamount province. That's a chain of volcanic formations that appeared after the supercontinent Gondwana had broken apart over 100 million years ago. Their computer models and chemical tests showed that right after the supercontinent Gondwana broke apart, a lot of magma with unusual chemicals pushed up to the surface. Over millions of years, this chemical signature slowly faded as less material came up from under the continent. The most unexpected discovery is that this happened without any help from those deep, hot columns of rock scientists used to think were needed. Now, to get an even clearer picture, let's sneak a peek into our planet's insides. Earth is about 4.6 billion years old. It was born from a huge cloud of dust and gas that slowly cooled, shrank, and hardened into the planet we know today. As it cooled, heavy metals like iron and nickel sank to the center, and lighter, rocky materials floated upward. This created the Earth's layered structure, with each layer having its own unique properties. The crust is like Earth's skin. It's our planet's outermost layer made of solid rock. It's broken into huge pieces called tectonic plates that slowly drift over time. There are two kinds of crust: oceanic crust and continental crust. The oceanic crust is about 4 to 6 miles thick. It's covered with a thin layer of sediments like sand, clay, and shells. Below that are dense rocks like basalt, rich in magnesium. As for the continental crust, it's thicker than oceanic crust and is located under continents. It's made of lighter rocks than oceanic crust. Beneath the crust is the mantle. It makes up more than 75% of Earth's volume. The top of the mantle is pretty rigid, but deeper down it becomes soft and partially molten, which allows it to flow slowly. This flow is what moves the tectonic plates. At the center of the Earth lies the core. It's made mostly of iron and nickel and has two distinct layers, the outer core and the inner core. The outer core is a liquid layer of iron and nickel. It's insanely hot, up to 10,800 degrees Fahrenheit, as hot as the surface of the sun. The outer core also generates Earth's magnetic field, which protects us from harmful solar radiation. The inner core is solid because of the crushing pressure inside the planet. It's also made of iron and nickel. Now, the Earth's outer shell, called the lithosphere, is made up of the crust and the uppermost part of the mantle. It's broken into large pieces, called tectonic plates. There are a few super large plates and many smaller ones. 6 of the major plates are named after the continents they carry, like the North American, African, and Antarctic plates. But even those smaller plates play an important role. For example, the tiny Juan de Fuca plate is responsible for many of the volcanoes in the Pacific Northwest of the United States. The plates are moving like a jumble of old conveyor belts. They move very slowly, about 1 to 2 inches per year. But over millions of years, this movement shapes the face of our planet. Most earthquakes, volcanoes, and mountain building happen where plates meet, pull apart, or slide past each other. There are 3 main types of plate boundaries: convergent, when plates move toward each other; divergent, when plates move apart; and transform. That's when plates slide sideways past each other. When tectonic plates collide, the crust crumples and buckles, forming mountain ranges. About 55 million years ago, India crashed into Asia, slowly creating the Himalayas, the tallest mountains on Earth. The collision continues today, so the mountains are still rising. Mount Everest, the highest point on Earth, may even grow a tiny bit taller over time. At some convergent boundaries, an oceanic plate dives under a land plate in a process called subduction. The land above lifts up, forming mountains, and the sinking plate melts and triggers volcanic eruptions. This is how some mountains in the Andes of South America were formed. When two oceanic plates collide, one usually slides beneath the other, creating deep ocean trenches, like the Mariana Trench in the North Pacific, the deepest point on Earth. These collisions can also form underwater volcanoes that eventually rise above the ocean and turn into island chains, such as Japan. At divergent boundaries, tectonic plates move away from each other. In the oceans, magma from deep in the mantle rises to fill the gap. This creates underwater mountains and volcanoes along the seam. This process renews the ocean floor and slowly widens the ocean basins. By the way, a single mid-ocean ridge system connects all the world's oceans, making it the longest mountain range on Earth. On land, when plates pull apart, they form giant valleys, such as the Great Rift Valley in Africa. If this stretching continues over millions of years, East Africa could split off to become a new landmass. One famous example of transform boundaries is the San Andreas Fault in California. Unlike convergent or divergent boundaries, transform boundaries usually don't create mountains or oceans, but the grinding motion can cause powerful earthquakes, such as the 1906 earthquake that destroyed much of San Francisco.
If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupao as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these 2 being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.
A massive area is shaking with earthquakes, and the Indian plate is splitting into pieces beneath the Himalayas. The alpine Himalayan belt runs for about 6,800 miles across southern Europe and Asia. This is where giant tectonic plates, Africa, India, and Arabia, push directly into Eurasia. This squeezes the crust, it bends, and slowly, massive mountain ranges, like the Himalayas, rise out of the ground. This region is one of the most active earthquake zones on Earth. Since 1900, earthquakes here have taken the lives of over 10,000 people. If the alpine Himalayan belt suddenly went into a strong earthquake phase, the impact would stretch across a massive region, from southern Europe through Turkey and Iran, all the way to Pakistan, India, Nepal, and parts of China. The first hit would be buildings and infrastructure. In many cities along the belt, older or poorly reinforced structures would collapse because of strong shaking. Hospitals, schools, roads, and bridges could be damaged or cut off within minutes. In the mountains, landslides would block valleys and trap entire communities. But the biggest issue wouldn't just be the shaking itself. It would be the aftermath. Millions of people would be forced out of their homes, since aftershocks would keep coming, and whole regions would stay unsafe for days or weeks. Economically, things would spread fast. This area includes major transport routes and industrial zones, so damage to roads, railways, pipelines, and power grids would mess with supply chains across several countries at once. That means delays in food, fuel, and goods far beyond the earthquake zone, and the recovery wouldn't be quick. Years of rebuilding, especially in remote or mountainous areas, with extra complications from landslides, river blockages, and secondary flooding. In other words, it wouldn't be one isolated disaster. It would be a chain reaction across a huge part of the world. We can't do nothing and just watch the disaster unfold. The consequences will be terrifying. Unfortunately, until recently, no one could actually track how the ground deforms across the whole region in detail. There weren't enough ground sensors, and a lot of what was happening underground was basically guesswork. Sounds like we're doomed, but several new studies can save thousands of lives and protect dozens of cities from serious damage. Scientists are finally able to track how the ground moves across the whole system in detail, which is crucial for people living in that region and infrastructure. A new study is based on over 222,000 satellite radar images from Sentinel-1, a European Space Agency satellite constellation that gives us all-weather, day and night radar imagery of Earth's surface. These images were matched with GPS measurements from ground stations spread across the region. This is the first time scientists have been able to see the whole collision zone clearly, with detailed information showing how the ground is moving across it. And it detects subtle but non-stop movement. Some areas slowly shift year after year. Other parts are stuck, but it's even worse. It means that pressure is building underground year after year, and that pressure won't just disappear. It will build up inside faults that run deep beneath highly populated cities, mountains, and valleys. In the end, the picture turned out to be pretty messy. Apparently, the ground doesn't only move along the big, well-known faults like those in Turkey or the Tibetan Plateau. It happens across wide regions between major faults. The crust is being pulled and pushed in different directions all across the area. Now, once you know how the ground is moving, you can see where it's loading up stress, and that's the key to earthquake danger. Until recently, scientists had to rely mostly on ground stations, but those are located far apart and spread unevenly across the alpine Himalayan belt. The new satellite map changes everything. Now scientists can zoom in and actually see how the ground is moving and where stress is building. And that matters because earthquakes don't happen randomly. They often hit where stress has been stacking up for years, or even decades, until the rock finally breaks. Speaking of rock breaking, one of the most massive slow-motion crashes on Earth is still happening right now. Around 200 million years ago, Earth had a supercontinent called Pangaea. Then it started breaking apart. Pieces drifted away, and one of them, the Indian plate, broke free and started racing north pretty fast. It was dashing forward at about 3.5 to 6 inches per year, which is a lot. For tens of millions of years, it kept going until it slammed into the Eurasian plate around 50 million years ago. That's when things changed. The speed dropped to about 1.5 to 2 inches per year because the plate started pushing into another continent and met resistance. The ocean locked in between, the ancient Tethys Ocean, started closing. The crust crumpled, rock folded, and the land had nowhere to go but up. That's how the Himalayas formed, and they're still rising today. Even now, the Indian plate keeps pushing north at about 2 inches per year. Also, over time it adds up. That pressure lifts the Himalayas every year and constantly reloads stress in the crust around them. That's why this region produces so many earthquakes. Scientists have studied this collision for decades, but it's still messy and hard to understand. The rocks don't behave in simple ways, since different parts of the crust respond differently. So in new research, experts tried something more controlled. They built a simulation to recreate the collision in a virtual model. Then they changed the speed of the plates and watched what happened inside the system. They wanted to understand why this collision zone is still one of the most earthquake-active places on the planet. It turns out that the Indian plate is not behaving like one solid block. Deep under the mountains, it's constantly stretching, bending and tearing, all the while pushing into Eurasia. And that completely changes the picture. For a long time, scientists imagined the Indian plate like one strong piece of crust smashing north into the Himalayas. But this new research suggests that something way more unstable is happening underneath. The plate itself is deforming as it sinks and collides. In the western Himalayas, the old model still kind of holds. The Indian plate stays mostly intact and keeps sliding beneath the Tibetan crust in a relatively stable way. But closer to the east, the Indian plate doesn't stay whole. Instead, its deep layer, called the lithospheric mantle, is starting to separate from the upper crust. The bottom part sinks deeper into the earth, and the top keeps pushing forward. This tearing process is called delamination. So instead of one clean collision building the Himalayas, we see a plate that's not only crashing into another continent, but also falling apart from within while doing it. It means there's an invisible but very powerful engine behind the entire region. The same forces that built the Himalayas and Tibetan Plateau are still active today. They're grinding and reshaping the crust from below. It's a deep and messy process. The plate is getting bent under crazy pressure, and the mountains above it are rising and shifting because of it. The Himalayas are still under construction, and the ground beneath them is far from stable. This changes how we think about risk in that region. If the Indian plate is really tearing under Tibet, it makes more sense why some parts of the Himalayas keep shaking. The pressure doesn't spread out evenly. It builds up in certain spots underground, and then suddenly lets go as earthquakes. It also means Tibet isn't sitting on some fixed, stable base. The deep layer under it is still being reshaped from below. New material keeps moving in, where the plate is breaking apart and shifting. And that goes against our old idea that continents move like solid, rigid blocks when mountains form. Apparently, the crust is more like something that is constantly under pressure. It bends, cracks, and rearranges itself as it moves. So the Himalayas aren't some finished structure, they're still being built. The Indian plate keeps pushing in, Eurasia resists, and deep inside the earth, rock keeps flowing, tearing and shifting. What you see on the surface, the peaks, valleys, and ridges, is just the visible layer of a much bigger system.
Something catastrophic is going on off the northern coast of California, and it could turn into a real disaster, affecting millions of people and destroying entire cities. Scientists have just found hidden fault lines there, cracks in the earth that no one fully saw before, and it means the region is likely to be more unstable than we thought. The area is called the Mendocino Triple Junction. It sits offshore where huge tectonic plates meet and push against each other. For a long time, experts believed only 3 tectonic plates were clashing there. That alone already made it one of the most active earthquake zones in the United States. A massive rupture at the Mendocino Triple Junction probably wouldn't change Earth's climate or destroy the planet, but the regional damage could be catastrophic. A massive quake could trigger tsunamis, fires, landslides, and even flooding. There would be widespread infrastructure collapse across the West Coast. Even worse, the impact might not stay local. Ports, shipping routes, energy systems, internet cables, and supply chains would all take serious hits. It would impact economies far beyond the United States. And now it turns out that there are not 3 plates in that region. There are 5. 2 of them were hidden. They're moving deep below, out of sight. But they still add pressure, and pressure like that builds, spreads, and locks into the crust. Besides, this place is where several large fault systems collide. The San Andreas Fault runs into it. The Cascadia subduction zone connects nearby. Another fault cuts across from the side. And all these systems interact, push, and pull at the same time. This creates a zone where the ground is constantly under stress. It may be building in ways we weren't tracking, and some of it could be locking up along hidden faults, storing energy over time. When that energy releases, it won't be a slow, quiet event. In a worst-case scenario, it could trigger devastating earthquakes, potentially reaching magnitude 8. That level of shaking can cause widespread damage across cities, infrastructure, and coastal areas. Millions of people live along this part of California's coast. Roads, bridges, power lines, and entire communities are located on top of this system. And now we know that this region may be more unstable than anyone realized, and the real risk might be higher than expected. It turns out, before we were only seeing the surface. Most of the action was hidden. So researchers set up a network of sensitive instruments across the Pacific Northwest to see what was going on under that part of the coast. These devices picked up tiny low-frequency earthquakes happening deep underground, so small they don't even reach the surface. But down below, they show exactly where the plates are grinding and moving. Those weak signals reveal that parts of the Earth's crust were breaking apart and sinking in ways no one had mapped before. One piece of the North American plate has actually snapped off. Now it's being dragged downward along with another plate, called the Gorda Plate, right at the edge of the Cascadia subduction zone. There was also another buried fragment, a leftover piece of an ancient plate that sat along the California coast millions of years ago. Most of that old plate is gone now, but this chunk didn't vanish. It's still there, and it's being pulled under the continent. and it's happening in a more tangled way than anyone expected. Even the depth of all this is different from what scientists thought. These plates are closer to the surface, and that explains one mystery. The powerful magnitude 7.2 earthquake that hit Humboldt County in 1992 started at a relatively shallow depth, which made the shaking stronger at the surface. Now it makes sense. The source just wasn't as deep as expected because the whole system sits higher up. And one more thing changed. Scientists thought the main fault lines had a clean edge where one plate slides under another. But in reality, it's more scattered, which makes it harder to track. The area looks like a tangled system of broken pieces, all moving, pushing, and slipping underground at the same time. To make sure this wasn't a mistake, researchers also used models based on ocean tides. Every day, tides push and pull on the Earth's crust, adding small amounts of stress to the rock below. So we can track how the ground responds to that stress and understand what's happening underground. Well, the results were the same. It's obvious that earthquake models for this area needed to change. The risk might be higher than we thought. The boundary is off. The whole area is closer to the surface than we previously thought. Plus, there are two danger zones in this region: the San Andreas Fault and the Cascadia Subduction Zone. Both can produce very large, destructive earthquakes. The San Andreas Fault is one of the most dangerous places on Earth. It stretches for about 750 miles. This is where two huge pieces of Earth, the Pacific Plate and the North American Plate, grind past each other. Every once in a while, they suddenly snap, and that's when earthquakes hit. Even though the plates move only about an inch per year, that slow motion adds up, and stress builds deep underground. In the north, the fault disappears into the ocean. In that place, things get even more intense because it's a zone where multiple tectonic forces collide. This is one of the most unstable regions in the US. A massive earthquake from a nearby subduction zone might set off a chain reaction and trigger movement along the San Andreas itself. In the south, the fault reaches an area near the Salton Sea. There, the ground starts to pull apart. The crust is stretching, thinning, and slowly breaking. It can eventually create a new ocean basin. Right now, sediments from the Colorado River are filling that gap and holding back seawater. But the ground is shifting underneath. The fault was first identified in the late 1800s, but its power became obvious after the 1906 San Francisco earthquake. When scientists made the map of the devastated area, they saw one long, almost perfect line. That line was the fault. A massive system capable of moving entire sections of land. Today, scientists are still trying to understand how it behaves. They've even drilled directly into the fault to study it from the inside. This is important because it's constantly moving, locking, and building stress. And no one can say exactly when the next big rupture will happen. As for the Cascadia Subduction Zone, it's just as dangerous. It runs for about 620 miles, from Northern California all the way up past Oregon and Washington into Canada. But you won't see it on land. It sits offshore, about 70 to 100 miles out in the Pacific Ocean. Down there, a smaller ocean plate is slowly sliding under the North American continent. When this zone ruptures, it can produce a megathrust earthquake, the largest kind on Earth, magnitude 9 or higher. The last time it happened was in 1700. Since then, the plates have kept pushing, and for more than 300 years, stress has been building along the entire fault. When it releases, the shaking could go on for 5 to 7 minutes along the coast, and that would be just the first hit. A quake that big would also trigger a tsunami. Waves could rise over 100 feet high and race toward the coast. In some places, they could arrive in 10 to 15 minutes. That's barely enough time to react. Entire coastal areas could be hit before people even realize what's coming. And the damage wouldn't stop at the shoreline. Cities like Seattle, Portland, and Vancouver are located in the impact zone. Power, water, and communication systems could go down all at once, and millions of people would be affected. The ground could sink by several feet in some areas. In others, it could turn unstable, causing buildings to tilt, slide, or collapse. And since much of the infrastructure in this region wasn't built for shaking this strong or this long, when it happens, it will be a chain reaction: shaking, collapse, flooding, and eventually, isolation. Now, we need to understand the tectonic process in the region, because when it comes to earthquakes, getting the details right can make the difference between being prepared and being caught off guard. Nobody tells you that while you're admiring the astonishing nature of Iceland, it's actually being ripped in two at the same time. When we talk about geological threats, we usually think about sudden, brutal acts like coastal storms or earthquakes. Well, actually, what's happening right in the middle of the freezing ocean is far more terrifying than that, and completely different. The entire country and island of Iceland is actively tearing itself into pieces at a super slow pace. The reason for that is the exact same force that originally created the Atlantic Ocean. It's all about two gigantic tectonic plates pulling away from each other. One is drifting west toward America, while the other is moving east towards Europe. We're talking about roughly 2 centimeters per year. It doesn't sound like a horror, right? But this continuous mechanism is currently unleashing a geographic and economic nightmare, not only for Iceland itself. Unlike anywhere else on the planet, this particular split is taking place entirely above water level. You can even jump from one continent plate to another. At first, it was just a stunning geological spot, a tourist attraction. What about now? It literally becomes a trap for people living right on top of it. Let's dig deeper. Why is it breaking? Well, Iceland sits perfectly across the mid-Atlantic ridge. It's a 16,000-kilometer underwater mountain range. Usually, this scar is totally hidden beneath the ocean. But not here. A massive mantle hotspot sitting right below the island forced the land out of the water. This exact combination of hotspot pushing up and tectonic plates pulling apart is violently tearing the island in half. Schema goes like this. Ground pulls apart, deep voids are being created in the crust, and then super hot magma instantly rises up from the mantle to fill the gaps. Tens of millions of years ago, this exact same process created the oceans we know today by pushing ancient supercontinents apart. Math isn't exactly on their side. 2 centimeters a year. Over a million years, that's a 20-kilometer split right in the middle of the country. But we don't have to wait all these years to see the devastating consequences. It's happening right now and directly targeting the most populated and vital economic area of Iceland. For centuries, everything was fine. People built an advanced society on this volcanic rock. A quiet, wealthy life. But it's like walking on a sleeping giant. As the interior of Iceland is a freezing and inhabitable desert, 80% of the entire population lives in the southwest corner, mostly on the Reykjanes Peninsula and around the capital of Reykjavik. It's where the critical infrastructure like the major airport and the world-famous geothermal power plants are located. Last time this region tore open happened in the ancient times of Norse Vikings until late 2019. A terrifying 1,000-year eruptive cycle suddenly woke up. Back then, massive eruptions ruined land, poisoned air, and pushed medieval communities into the edge of starvation. But this time, it's happening to a modern, highly developed nation with billions of dollars of immovable infrastructure sitting directly on the fault line. It wasn't a classic mountain erupting. The tectonic plate boundary acts as the volcano. The rock stretches, fractures, and creates miles-long underground networks of fissures. Magma instantly floods into these cracks and creates extremely high pressure just a few kilometers deep under people's feet. Since 2019, it's not quiet anymore. In early 2021, more than 40,000 micro-earthquakes shook the region within weeks. These are called seismic swarms. People of Iceland treat them as a geological warning siren, as the psychological and social toll is absolutely staggering. Then came late 2023. The economic reality of a splitting Earth hit hard. The city of Grindavik, home to nearly 4,000 people, sat right in the epicenter of these swarms. The ground didn't just shake, it physically tore apart. Foundations of the entire town, houses, streets just cracked in half. The entire area had to be evacuated overnight. Icelanders described it later as the country's most severe natural disaster in over half a century. Thousands of people instantly became geological refugees. You cannot simply rebuild a damaged building when the actual soil beneath your property has physically split open, revealing a glowing abyss. Since this event, the city of Grindavik remains a ghost town, as people's entire life savings locked into real estate vanished into a tectonic crack. The financial shockwave after this geological nightmare hit the entire country, even creating a real threat to Iceland's broader economy. The property values in a major economic zone dropped to zero within hours, causing a crisis in the national banking system as thousands of mortgages suddenly became tied to worthless land. To prevent a total collapse, the Icelandic government was forced to step in and buy out the ruined residential properties. It was a colossal financial burden to the country. At the same time, national insurance companies realized that basically no policy in the world is designed to cover a continent-splitting open event. There was also a real threat to the absolute lifeblood of the Icelandic GDP: tourism. Even the international airspace was in danger. Every single time a new fissure erupts, toxic gas clouds can shut down airports, cutting the island from the world. And it can cost millions of dollars a day. So, what do you do when the Earth's core tries to rip your country apart? You fight back. Icelandic scientists decided to do the impossible: engineer their way out of a tectonic trap. As magma pushes to the surface, threatening incredibly vital targets like the Svartsengi geothermal power station and the iconic Blue Lagoon Spa, local authorities launched the most ambitious lava defense project ever attempted in human history. They didn't just put simple fences up. They constructed multi-kilometer barriers reaching up to 24 meters high. These are massive fortifications, mountains of basalt gravel and heavy boulders designed to resist enormous temperature and pressure. You can't stop the lava. That's impossible. But you can steer it, push it away from the people and the crucial infrastructure. Engineers managed to predict exactly where the molten rock will flow by using advanced fluid dynamics software, originally designed by the military to force the flood. Hundreds of people were rushing to build these massive walls, working so close to the lava they can physically feel the burning heat. Here's the brutal truth about living on a cracked Earth: you cannot save everything. These new barriers held. The power plant was saved, but the car parks or people's homes, they had to be sacrificed, left to be swallowed whole by the molten rock. Authorities have to decide what survives and what essentially burns. And what's even worse, no matter how thick and tall the wall will be, It won't protect anything when the fissure opens up directly underneath the pavement. Scientists are warning us. This isn't just a random blip. This highly destructive eruption cycle could easily last for the next hundreds of years. The map of Iceland is literally being redrawn in real time by fire and splitting rock right before our eyes. The tectonic plates won't stop moving, and the split will continue. It is the ultimate geographic paradox. The exact same forces that originally created this island, providing the free geothermal energy that made it rich, are now actively threatening to tear its economy and its communities to pieces.
The prehistoric landmass Doggerland wasn't some empty wasteland during the last ice age, like scientists used to believe. It was alive, full of trees, animals, and maybe even people. And then the North Sea swallowed all of it like it never existed. So, no, Doggerland was not some ancient gigantic dog pound, although that would have been cool. It was a massive stretch of land that used to connect Great Britain to mainland Europe. You could have walked on it from modern-day England to the Netherlands without seeing water. Rivers cut through it, animals migrated across it, and early humans likely followed those same routes, finding prey, gathering, and building their lives on this land. Then, glaciers melted and sea levels began to rise. Doggerland was drowning slowly. Land turned into wetlands, and wetlands broke into islands. Islands shrank year by year. Forest paths turned into marshes, and rivers widened into channels. And eventually, somewhere between 10,000 and 7,000 years ago, the sea finished the job. But now, scientists have pulled out evidence of a full forest ecosystem that existed here over 16,000 years ago, thousands of years earlier than previously thought. They used sedimentary ancient DNA analysis to figure it out. Every living thing leaves behind tiny traces of itself, microscopic fragments of DNA, and those fragments can get trapped in mud and sand. Over thousands of years, layers build up, and those fragments stay there, like fingerprints pressed into wet cement. Scientists drill down, pull up those layers, and read them like a timeline. When they analyzed sedimentary ancient DNA from 252 samples from 41 marine sediment cores, they found traces of oak trees, elm, hazel, real temperate forest species. And they weren't just surviving there, but thriving more than 16,000 years ago. That's deep into the last ice age, a time we've always imagined as brutal and lifeless, especially in northern Europe. But instead of a frozen desert, it looks like this area was a hidden pocket of life. And this wasn't just a temporary burst of life after the ice, but a deep-rooted ecosystem. It was stable enough to support large trees with massive root systems. You don't get that unless the soil holds together, unless there are seasons, growth cycles, and enough balance for life to settle in and stay. Among all the DNA, scientists found traces of a tree called Pterocarya, a distant cousin of modern walnut trees. The weird part is that researchers believed it disappeared from that region around 400,000 years ago. But somehow, it held on here, and that detail changes how we understand extinction. It could mean that species don't always vanish completely. Sometimes they retreat, hide, and survive in small pockets we just haven't discovered yet. All this means that parts of Doggerland probably remained above water during major flooding events, like the Stagaga tsunami around 8,150 years ago. This means this land didn't just vanish, it resisted. It broke apart slowly, holding on in fragments before it finally disappeared. But actually, all of that still exists. It's not alive or visible, but preserved under layers of seabed and miles of seawater. Ships pass over it every day. Waves roll across it. If you could somehow drain the North Sea for a moment, you would see those old river channels carved into the earth, soil layers, and maybe even preserved roots where trees once stood. Another cool detail is that scientists think Doggerland might explain why traces of early humans in Britain seem so scattered. If people lived there, and it's very likely they did, then when the sea swallowed the land, it swallowed their history with it. Campsites, tools, pathways, and entire communities were all gone. Now, Doggerland isn't some one-time anomaly, so let's jump to the extreme opposite: Antarctica, with its endless ice, brutal winds, and temperatures that don't forgive anything. You look at it and think nothing survives here. But scientists walked across it and proved that idea completely wrong. Between late 2019 and early 2020, a team trucked across a remote part of Antarctica. Their instruments picked up something strange under their feet. Not solid ice as they expected, but something softer. So they drilled. Layer after layer of ice came out, until about 40 feet down, they hit something impossible: liquid water. It was a lake hidden under ice in one of the harshest environments on Earth. They tested the water, trying to understand where it came from. Because this place doesn't get much snowfall, the wind strips moisture away. Sunlight evaporates whatever little exists. So, how does a lake survive here? The answer is chemistry. Tiny traces of dissolved materials in the water help scientists find a hidden source. It turned out that a nearby glacier feeds the lake through underwater pathways no one knew existed. And then they looked closer and found microbial mats, living carpets made of microscopic organisms inside that dark sealed environment. Some stretch flat across the lake bed like rugs. Others grow upward in spiky shapes that rise up to about 15 inches tall. That's over a foot of life growing in total darkness, under thick ice, completely cut off from the outside world. And this life doesn't just exist, but organizes and changes over time. It's structured like a miniature forest floor, just in a completely unusual form. Another Antarctica discovery that shocked scientists was bubbles. They sit inside what might be the oldest ice ever brought up into daylight, nearly 1.2 million years old. Now, before this, researchers could only track Earth's climate history back about 800,000 years. That already felt ancient, but it still left a huge chunk of our planet's story missing. So scientists went looking for the right ice to fill in the gaps. Some parts of Antarctica actually hold ice that could be 3 or even 4 million years old, but it's messy and incomplete. They needed a clean timeline, layer after layer, year after year. So they spent years searching for that perfect spot, scanning the frozen continent like detectives looking for a buried archive. And when they finally drilled down into the ice at just the right location, they hit something special: crystal clear ice cores, stacked like a frozen timeline with tiny bubbles inside. Each one came with a microscopic sample of ancient air, sealed off from the world for hundreds of thousands, sometimes over 1 million years. When scientists study those bubbles, they can figure out what the atmosphere looked like, what gases filled the sky, how much carbon dioxide floated around, and how the planet's climate shifted over time. One moment locked inside that ice stands out more than most: the period around 900,000 years ago. That time might have been one of the closest calls our species ever faced. According to genetic studies, back then, the human population dropped to around 1,300 individuals worldwide. Nobody knows exactly what caused it, but climate is one of the biggest suspects. Massive environmental shifts, changing temperatures, unstable ecosystems, everything could have stacked against early humans at once. And those bubbles might hold clues to what kind of world those few survivors had to endure. So when scientists look inside one of those ancient bubbles, they're tracing survival. They're asking how a handful of humans made it through one of the toughest chapters in Earth's history, and what that might mean for us today. And when scientists scanned Antarctica from space, they found something even harder to wrap your head around. Beneath over 6,000 feet of ice, They detected an ancient landscape. Not rough shapes, but actual terrain with valleys carved by rivers and land split into blocks by tectonic forces millions of years ago. A place where water once flowed freely across the surface. This landscape dates back around 34 million years ago, to a time before Antarctica froze over completely. And somehow, in this one region, the ice didn't grind it away. It just sat on top of it, frozen in place, and preserved it like a time capsule. Scientists described it as a ghost because it shouldn't still exist. Most landscapes get reshaped, erased, recycled by Earth over time, but this one just stayed. When you connect all of this, you can see that Earth doesn't change slowly and predictably. It hides things like entire ecosystems and histories. We walk around thinking we know this planet, but underneath us, under oceans and ice and layers of time, there are entire worlds we haven't even touched yet.